Let's clean this up a little bit. It's looks pretty ugly. Let's style it a little bit using Bootstrap, so that if we go in here, and if we're in the right location, we can do npm install Bootstrap, and don't forget to save. Or you probably already have Bootstrap installed, so you won't need to do this. But I don't. Oh, okay, yes. So the inheritance part, let me talk about that a little bit. Right, so we're using a strategy called the single table inheritance strategy. Also, there's another name called the denormalized strategy. Right. So the idea is that there's several ways of implementing inheritance. Right. So if you have a hierarchy of tables that of classes that are inheriting from another, right? Where you have A, B, C, D, and E. One way to implement this is to create classes. Creating a table for each one of these, right? That's called the one class, one table strategy, right? And the way you implement this is that you have a table, right, with all the fields for A. Then you have all the tables for B, right, all the fields, and then I guess I should draw this. You would have a table for B with the fields for B, and you would have a table for C with the fields for C, and so on and so forth. So the strategy would be that you would have A, the table A only has the fields that are in common to everybody, right? Just like you have in a class diagram, right? So A would only have the fields for in the class A. B would have always the fields for the fields in B. One class, one table, right? That's pretty straightforward. And the implementation would be that A would have a foreign key. I would have a primary key. So each record here would have a primary key, right? And obviously these records would have also their primary key, but their primary key would also be a foreign key. Okay? That would be referring to the record that goes along with that. So because if you want an instance of B, yes, that instance of B will have the fields of not only B but also the fields that are inherited from A. Right? So an instance of B is really the combination of the fields from the one that is inherited with the one that it declares, right? So whenever you want to grab an instance of B, you have to join B and A, right, together to grab all the values from A, grab all the values from B. You have to join those two, right, with foreign key and primary key. And now and that's all in good, right? And certainly JPA can do that for you. It'll split it up into multiple tables. Now the problem with this implementation, if you have D and E, the problem with that implementation is that you have to join, right? And joins are typically a very expensive operation. Okay? If you're doing a join between two tables, that's not too bad, right? But every time you do a join, like for instance, if you need to grab A and C, if you grab some from C, you need to join A and C, right? Because you have a foreign key from C going back to A. But if you want to grab a field, a record from D, you need to join the record in D together with the record in C together with the record in A. So you have a three-way joins, right? So you have one join, additional join per level of inheritance. Right? So that becomes expensive, right? This is linear. So iterating over one table is linear, right? If you join two tables, that's quadratic, right? If you join another one, it's cubic, right? So it's very common in Java or in object-oriented languages to have fairly deep hierarchies, inheritance chains, right? And you would have to join all the tables. So oftentimes we avoid this implementation, right? This is called the normalized implementation, normalized. Okay. There's a different way to do this, is to use what's called the denormalized implementation. right? The denormalize implementation, what it says is that, you know what, this is very expensive, right? It's very elegant and everything, right? It's very pretty, but instead, I'm going to do something that we've been taught not to do, but here we're very well justified, right? We're going to denormalize this. We're going to flatten this hierarchy into a single table. Right? We're going to grab all the fields from B, and we're going to put them in A. We're going to grab all the fields in C, and we're also going to put it in A, D, E. All of them are going to live in a single table. Right? That's why we call it denormalize. Right? And so what this is going to look like instead is this. Right? One big table, A. Right? But it's going to include fields from B, from C, from D, and from E. Plus an additional field. Right? The type field. The type field is an additional field that tells how should a particular record be interpreted. Right? So if the original type was B, right, then it should be interpreted. Then only the values, these three values, make any sense. Everybody else says, I'm not C, I'm not D, I'm not E. Right? So all those values would be null. Right? If the type is C, then only the values under C make sense. Everything else is null. Make sense? Right? So now here there's no joins. There's no join, so the access to this is very, very fast, right? There's no need to join this with anyone else, so it's linear as opposed to quadratic. But what you're doing is here is that you're trading space for time, right? Notice that you're going to have lots and lots of empty, very sparse table, right? So lots and lots of nulls everywhere, which from a DBA's point of view, that's they'll cringe and says, you have all this empty space, that's fine. Here we're justified, right? We're just mapping, something that we just can't do in relational databases, right? And the actual way of doing it is very expensive. Okay. There's yet another implementation. So this is the way I'm asking you to do it, right? So notice that here we have a widgets type. That's going to be our type, our T over there, right? That's going to have. Notice that source is empty, right? That's for the image widget, right? And items is for the list widget, right? So those are null because I am not an image widget. I'm not a list widget. If I were, I would have values for those fields, and I wouldn't have values for the other ones, right? And how do I interpret whether you're one or the other? Is by looking at the widget type. Okay? All right. Yes.
So mapping this to JPA, is there like an annotation that'll take your
No,
class hierarchy?
There is, but we're not going to get into it.
So just make it one big class.
Just one big widget class.
Okay.
Yes. Next week we'll add inheritance where the classes will actually inherit from each other. Right? For instance, actually I was playing around with it, and this D type is what JPA created for itself. Right? JPA, instead of us handling the widget type, JPA creates it for you. Right? If you create the hierarchy, the class hierarchy, it creates a D type and it adds all the fields and it just flattens the whole thing, right? And you can tell it. You can tell it which strategy you want. Do you want the flat version or do you want the one table per class? And we'll play around with that. There's a third option. The third option is it's kind of a marriage between the two, right? A marriage between the two where what you have here is that here you have A, right? And you have fields for A. And here you have B, and you have the fields for B, plus you add the fields for A. So you still have one table per class, but you denormalize you don't denormalize up, you denormalize down. You flatten down, right? You copy the fields from your parent down to your children, right? And the data is actually stored here. So you have the best of two worlds, right? You're denormalized. You have one table, one per class, right? So you're back to your kind of more elegant solution, right? But the data lives at the leaves. So I don't need to join table B with table A. I don't have to have that expand. Same thing if you have C and you have D down here and E, right? E would be denormalized. It'll have all the fields for A, all the fields for C, and all the fields for D, right? All normalized, squish all the way down. Yes.
So if you change the values in the A table with property.
Yes, exactly. So in there, your replicate, you have a replication of the values here and here, right? So typically we would not do that. Just like we wouldn't denormalize, we wouldn't do this. This would be redundancy, right? You have the data redundant in several places. Typically you wouldn't do that, but that's okay because JPA is the one who's handling all this, right? We call that managed redundancy, meaning somebody knows that we're doing redundancy and somebody's handling it for us, right? So we minimize any risks of inconsistency, right? Okay. So you wouldn't actually do this by hand, right? You would use a library that does this for you. All right, I think I'm going to leave it here.